Alright, welcome to this video. This video is for Drafting 60, taught by Dr. Sean Carney. This video is going to cover the architectural base drawing that will then be ultimately used for the course project in regards to the site plan as well as the architectural plan set. What you see before you are the commands that we will be going over for this video. So please take notes if you wish or follow along. The first command, what we're going to get into, is units. Since this is the architectural base drawing, all of the units have been set up accordingly to industry standards, but I wanted to go through the dialog box so that you can understand what is going on. So in the command line, we type units or shortcut UN for units and hit enter. We have our dialog box. You'll see in the length area the type of drawing units is going to be architectural, and the precision is going to be to the nearest 16th of an inch. Angle is going to be in decimal degrees, and precision is going to be to 4 decimal places. The critical component here is insertion scale. Insertion scale needs to be set to inches. If you change this, when we try to bring in the civil drawing as an XREF, it will not come in at the correct scale. Therefore, do not change this when bringing in your XREF using this units dialog box. Architectural, 16th, decimal degrees, precision, inches. So we're going to hit OK. The next command is going to be our XREF. XREF stands for external reference. An external reference is what we are able to use in industry to bring in other drawings into the current CAD file so that we can see and work with multiple drawings at once. A benefit of an XREF is the ability for multiple people to work on one project at the same time. So to access XREF, we're going to do XR as our command. And if we pull up our dialog box is as follows. The first entry in the dialog box is going to be the current CAD file. In an XREF dialog box, we're able to insert not only a DWG file, but if we pull down this arrow, we can see all of the components or types of files that we can insert into this CAD file. The most common being attach a DWG, attach an image, and attach a PDF. Other file types that you can insert are DWFs, DGNs, point clouds, and coordination models. So what we want to do is we want to insert a DWG. So if you come up here, make sure that you attach a DWG. If you select anything other than DWG, it will not be able to find the CAD file that we want to attach. Select the reference file. We're going to find the D60 civil drawing to use as our XREF. Once we select that, we hit open. And here we have our attach external reference dialog box. The name up here will be the name that you will be attaching, the file name that you will be attaching. If this is not the name that you want to attach or the file that you want to attach, you can hit browse and search for the correct file. A preview window will be shown to show what exactly the Drafting 60 civil drawing will look like. Okay? If this is not shown up on your preview window, or if a different drawing is showing up on your preview window, you have selected the wrong file. We want to make sure that our specify on-screen scale is not checked. We want the drawing to come in as 1:1. We also want to make sure that the specify on-screen insertion point is also unchecked because we want it to come in at the coordinates 0, 0. I always recommend, in terms of a path type, to use full path so that the computer can find the file path. If we were to close down the CAD file, reopen, it still can find the path. And here we have two different reference types. Reference type of an attachment for an XREF means that if I XREF this drawing into my file and somebody XREFs my file into theirs, they will be able to see all of the external references that I have inserted into my CAD file. If I choose the overlay option in my CAD file and somebody wants to XREF my CAD file into their CAD file, they will only see the base drawing and no other XREFs. For this purpose and this class, I recommend you do attachment. Then we're going to hit OK. You may see an option to select proxy graphics. What that means is that a file, an AutoCAD file specifically, has come from a different software such as Civil 3D. I would recommend you click Do Not Show Proxy Graphics if this dialog box comes up. If it is successfully attached, it will show up in your XREF window. We can then close that window. Now what we're going to do is we're going to find the drawing that was just inserted. If you see a black area, don't panic. The file has officially attached. To zoom extents in your window, if you have a mouse with a middle mouse button or a roller wheel, you want to double click that, and that is the shortcut for zoom extent. Alright, so now that we have attached our civil drawing file and we have zoom extents, we should see it in the model space. Okay? Now your specific view of it may be brighter in contrast than what I see here. To change that option, to change the ability to modify the contrast and intensity of the lines in your CAD file, what you can do is you can go to Options. You're going to go to Display. You're going to go to the lower right corner of the dialog box and change your fade control of XREF display to approximately 50. If I was to change that, for example, to -50, hit Apply and OK, you will see that it becomes much brighter. If we want to come back in there and change that to 50, it becomes more dim. Whenever I tend to XREF a drawing into another file, I like to see it faded so I know what is actually in my current CAD file and what is an XREF. Okay. So now that we have our XREF in our drawing, we now want to rotate our UCS. Rotating UCS allows us to have the specific property orthogonal on the view of the screen. So, for example, if I chose a lot that has a straight edge on the face, we can easily rotate that face so that it is orthogonal on the screen, meaning completely horizontal. Also, something to note is that when you bring in your civil drawing, the lines themselves, you may not see the integrity of the line or the line type. Remember that a civil drawing is in feet units. An architectural drawing is in inch units. So there is a scale factor of 12. If we change our LTS, which is line type scale, to, for example, 120, you may start to see the line types. If we do 240, you'll see the line types even better. But it doesn't change the fact or the idea that we're modifying anything in this CAD file. We're just changing the way we see lines by using LTS. Alright, so we're going to rotate this view so that we see the straight edge of a property line horizontal on the page or on the screen. So I'm going to choose 21 as my example. So what I'm going to do here is I'm going to do UCS. UCS stands for Universal Coordinate System and is the basis of every CAD file that we have for AutoCAD. Everything is in reference to the XY coordinate, the Cartesian coordinate. Everything has a location associated with that X coordinate and Y coordinate. The location of the XY coordinate is at 0, 0. Therefore, it is crucial that when you're rotating the view, you're physically rotating UCS, not using the rotate or align commands. If you use the rotate or align commands when rotating the subdivision, you will change the coordinate of that specific subdivision. So I want to rotate the view for lot 21. Again, I type UCS and I hit enter. Now we look at the dialog box on the cursor. It says specify origin of UCS. So I want to specify the origin of that lower right corner by using my O-snaps. And then once I do that, you'll see that I have full control over X and Y coordinate. Then I want to snap to the other corner of the front face. So if I O-snap to there we are. Then we look at the dialog box in the command line and it says UCS specify point on the XY plane or accept. I hit then accept by hitting enter. If I do it successfully, my cursor will then look like the same orientation as the XY Cartesian coordinate symbol. The X is represented by a brick colored line on the cursor, and the Y coordinate is identified by the light green line on the cursor. So the next step of this is we type plan. Plan means using the current UCS orientation, I can rotate the view to the exact horizontal location of the X and Y. I want to use current UCS, so I hit enter, and the view rotates. Okay. Next, what I want to do is I want to have CAD memorize this orientation as well as this location in the CAD file. So I type VIEW for view. I want to do a new view. I want to give it a name. So I will say lot 21 ortho, for example. I hit OK. A preview window shows up showing you what exactly you will see, and then we hit OK, so the CAD file will remember that specific location. Next part of this is I want to bring in the line work from the XREF using the command called NCOPY. So I type NCOPY, and here on this specific command we have to click all of the lines that represent what we want to bring in specifically to this CAD file. If we don't physically select each line, they will not come in to this CAD file. If there is a block in the civil file, you have to click each individual component of that block. So here I have selected absolutely everything that I need. Now I hit Enter. Here it says specify base point. I want to specify the lower left corner. So now I have full control of these copied lines, and I want to place them at the same point that I used as a base point. So it may not look like anything has occurred, but you will see that the XREF line work is still very dim and light. The line work that we have physically copied in is bold. The true testament is by changing the XREF to unload, in which case we're only left with the lines that we've brought in. If I go to my XREF menu and I right-click on the civil drawing, we have options to play with. We have unload, reload, and detach. Everything else we're not going to worry about right now. Unload means that we unload the XREF from the current CAD file, but it still stays attached. Meaning that if I want to bring back or turn on the XREF again, I would just hit reload. So if I hit unload, you will see that it disappears. And it will say in the dialog box, unloaded. If I right-click on the XREF civil drawing and click reload, it comes back to the same location. Lastly, if I hit detach, that means it completely detaches it from the CAD file, in which case I would have to then reinsert it and go through the XREF process again. So now that we've brought the drawing in to this specific file, meaning the line that exists for the specific lot that you will be designing on, then we can then offset and create our setbacks, which then create our building envelope. So first we want to do here is we want to do our layer manager, and we want to create a new layer for our setback line. So if we come into our new layer, we're going to do C dash site dash set B. What that stands for is C means civil, so it's a civil component, civil engineering component for the site plan and their setbacks. If you see a layer that begins with an A, that represents architectural layers. If you see layers that begin with an E, those are electrical layers. If you see letters or layers that begin with an F, those are fire layers. I represents interior, L represents landscape, P represents plumbing, and so forth. So I'm going to make that layer current by double clicking. I'm going to change the color to red and OK. And here we're going to change the line type to -2. Current layer is C site setback. Then I'm going to close that. So our front setbacks are 15 feet, our side setbacks are 15 feet, and our rear setback is 20 feet. So if I do my O for offset command, and we look at the dialog box, we have the ability to change the layer type and set it so that when we offset the property line, it will offset to the correct layer automatically. L for layer. I want to choose current, and here we're ready to go. So I want to type 15 feet. Because we're in the architectural drawing, everything is in feet and inches. If you were to physically just type 15 with no unit designation, it would offset it 15 inches. So whenever you want to offset to feet, you have to put the foot symbol. Then we're going to choose that front line and pull your cursor in the direction that you want it to offset. If I was to pull down, they would offset it into the street, and that's not what we want. We want it to offset into the property. Again, the side setbacks are 15 as well, so I'm going to click that and click in here, click that, click in here. Then I'm going to go to offset 20, click that, and see how I did 20 instead of 20 feet. You should see, in fact, the error. Okay? So I want to do O for offset, 20 feet, choose the back property line, and click. So this is our setbacks. These are our setback lines. So then we can fill it with a radius of 0 to bring these to a point on all 4 corners. So this is the building area that I can place my structure. The building area is also known as the building envelope. So using the building envelope, we can determine how much room we have to put in an 1,800 to 2,400 square foot house. Now, because this project is your project, you have the ability to design whatever shape you want, as long as the corners of the house are 90 degrees to one another. We don't want to do strange angles or curves for this particular project. So to determine how long my front limit is, I can click that line, I can type LI. When I do LI, that means list. It tells me the layer it's on, it tells me what it is, it tells me the coordinates, and it tells me the length. It's 70 feet long. Okay. So notice where the Cartesian coordinate is currently located. Be aware that when you change your UCS, it physically moves the coordinates of the drawing temporarily. Don't be alarmed. If we're looking at in the lower portion of the screen, you'll see X, Y, Z coordinates. If I approach that X, Y or XY coordinate, you'll see this area approach 0. Because my physical UCS was selected for that lower left corner. If I want to physically change the orientation of this UCS, I can hover over it and click World. But be aware, when you click World, your cursor will change. For example, the cursor is currently aligned with the current UCS. If I hover over the UCS and click World, you see the cursor change to true north and east. So don't be alarmed that if you ever see your cursor be some strange shape or angle, things can be resolved. If we want to physically change our UCS back to this face so that we can draw rectangles orthogonally along the bottom line here, again we do UCS, choose the lower left, choose the lower right, and accept. So we can always go back between world and current UCS. Okay, so again, if I list this line, it tells me it's 70 feet wide. If I want to see my building depth that I'm provided, I list that, and it's 106 foot 11 and 15/16 inches, which is approximately 107 feet. Okay, so if I have 70 feet wide in the front and 107 feet wide in depth, I have 70 times 107. I have 7,490 square feet to work with to put a 1,800 by 2,400 square foot house in that area, which is plenty of room. So from there, then we start to construct or start to lay out our house given the elements that we have to work with. When you're starting to lay out the house, look to see where your driveway can occur and look to see where various utilities are located. Typically, the utilities will come into the garage. So for this example, I would typically want the garage on the left-hand side and the house behind that. Or I want the whole house here, but the garage in the lower left corner. We'll go over this more when we work with bubble diagrams. If your lot is a lot that has a curve on the face, this is the part of the video that you will want to revisit. For example, if I was to choose lot 28, lot 28 has a nice line and a curve at the face. To get this line completely orthogonal on the lower portion of the screen, this is the process. I'm going to type UCS. UCS is going to be selected for one end of the line and for the corner of the lot. If you do it successfully, you will see the cursor change. We want to look in the command line and it says UCS specify point on the XY plane or accept. I want to hold my cursor on the side in which I want the X and Y coordinate to appear. If I hover over here, it would flip it. If I come over here, this is the orientation that I want. Hit enter to accept and it has accepted it. Because we have to visualize how we want, essentially we want this lower line to be horizontal on the page on the bottom. So then if I hit or type in the command plan and I use the current UCS, it will rotate it so that the X and Y is oriented to the normal location. Okay. So now what I want to do is I want to do NCOPY. NCOPY is going to allow me to bring in the line work and symbols that are required for this specific lot. Bring in all of the symbols associated with this lot and adjacent to this lot. If you don't select everything using the NCOPY, you can always re-enter into the command to then access the line work that was missed. So now I'm going to hit enter. Now it says specify base point. The base point is going to be any corner that you can physically O-snap to. So here I'm going to O-snap to that corner, which case you see the line work that would come in, or that will come in. Okay. The line work that comes in wants to be placed at the same point or same O-snap location that we chose as our base point. So I want to choose that same point again. Then if we come into XREF, we can physically unload the XREF. It shows that it's unloaded. We can then close that dialog box and we will see the lines that represent that specific lot. Then we want to make sure we're on the C-site setback layer. If I come into my layer manager again, C-site setback, red-2, close that, make sure that that is current. Then I'm going to take the front property line and offset it 15 feet back. O for offset, 15 feet. Choose this, choose that. The side setbacks are the same, 15. And the rear setback is 20 feet. Then I'm going to use my fillet radius of 0 to create my building envelope. My building envelope is created. Notice that my lines are individual. If I want to join them, I can use the join command. J for join. Select the two lines in the front. Hit enter. Then it becomes one line or one polyline. I can then list that, and it tells me that the total length of that front setback line is 109 feet 10 1/8 inch. The depth of the right line is 106 feet 11 15/16. This line is 104 foot 5 3/8, and the rear line is 79 feet 8 5/16. This gives us a large building envelope to design our house. This concludes this video. Please watch it and follow along as many times as you need to gather the necessary information to eventually set up your site plan. Thank you.